Assalamualaikum warahmatullahi wabarakatuh. This is video simulation of heat exchanger. In this video, we are going to explain about operation of heat exchanger, general startup, and co-current and counter-current difference. Firstly, the operation of heat exchanger. A double pipe heat exchanger is the simplest type of heat exchanger. In double pipe heat exchanger, one fluid flows through the smaller pipe while the other fluid flows through the annular space between the two pipes. There are two types of flow arrangement, which is parallel flow and counter flow. In this experiment, cold water flow at inner pipe while hot water flow at outer pipe.
So today I'm going to explain the general startup for this experiment. Okay, first, check the drain valve underneath the water storage tank is fully closed. Next, remove the cover from the storage tank and then fill the tank with the water within 40 mm. Replace the cover on the storage tank and then close the air bleed valve on the top of heat exchanger. Connect the cold water inlet to a source of cold water using flexible tubing. Connect the cold water outlet to a suitable drain. Number 7. Close the hot water flow control valve. Number 8. Set the temperature controller to 0 on the front panel. Switch on the pump and then observe the operation of the pump. Number 10. Raise the cover on the storage tank and observe the circulation of water through the tank. Open the hot water flow control valve and allow water to flow through the exchanger until a steady flow water is indicated on the hot water flow meter. Number 12. Open the cold water flow control valve. Set the selector valve to co-current position. Allow water to flow through the heat exchanger until steady flow water is indicated on the cold water flow meter. Close the hot and cold water flow control valve. Attach a length of flexible tubing to each of the air bleed valve at the top of the exchanger. Open each bleed valve and allow water to flow until all air is expelled. And then close the both bleed valve and remove the flexible tubing. Set the temperature controller to an elevated temperature, for example 50 degrees Celsius. Switch on the heater and observe the heater switch is illuminated, indicating power output to the heating element. Observe the heater in the storage tank and make sure it runs well. With that, commissioning is now complete.
Next, co-current and counter-current difference. This is diagram for co-current flow and counter-current flow. In parallel flow, hot and cold fluid flow in same direction. The temperature difference between hot and cold fluid decreases along the length from inlet to the outlet. In counter-current flow, the hot and cold fluid flow in opposite directions. The temperature difference between hot and cold fluid is maintained at a larger value. Lastly, why countercurrent has better performance? Data table from experiment show the efficiency of countercurrent flow is higher than co-current flow. Hence, log mean temperature difference for countercurrent flow also higher than co-current flow. The higher the log mean temperature difference value, the lower the area for heat exchanger needed. With the same area, countercurrent can perform more heat exchange than co-current. The overall heat transfer coefficient for countercurrent is higher than co-current, which means counter flow is better than parallel flow. Last but not least, counter current flow has lower percentage error than co-current flow. That's all from our group. Thank you.